Hi everyone and welcome to our Form 5 Chapter 2 Mathematics Matrix. This is our second class for our Form 5 Mathematics. Okay. This chapter is actually a quite new chapter and it will include how to solve simultaneous equation using this method. Now, I want to let you all about what is matrix. So, a matrix, we can say that is a set of the numbers that arrange in rows and columns to form a rectangular or a square array. Okay. Kalau untuk bahasa Melayu, matrix adalah nombor yang disusun dalam baris dan lajur untuk membentuk satu tata susunan segi empat tepat atau segi empat sama. Means, okay, all the numbers will be sit together in their own place. Okay, for matrix, we can using the table form and we convert through the matrix form. You see, this is the table form. Given item, okay, this is the first term, second term, third term. Okay, and we make it this together and to form this form. And when we using this form, okay, now when we already done for this, now I can say what is element, what we call as element in the matrix. Actually, matrix is a table and inside got element. The numbers we call it as a element. An element has their own representation, their wakilan, perwakilan. Perwakilan, okay, we can say that this is element A, this is a second row and the first column. Why we say that? First, we need to know about how to represent order of the matrix. So you see, we have 2 rows and 3 columns. So we have 2 by 3 matrix. Matrix that 2 by 3. We need to read the row first, and after that we see the column. Read the row first and later we read for the column. Same thing as a element. We say the row, later on we say the column. Baris lajur, baris lajur. Okay. If you know about this, then you can assume that if both matrices have their same order and the same element, we can say that M equals to N. This thing we can use for to find the value that we do know or unknown value in the matrix. And we need to know if 2 matrices are same order, what they can do. They can add together in the condition they are same order for sure. And each corresponding element is added or minus to obtain a single matrix. Okay, with the same order. Means first 2 by 2 plus with 2 by 2, your final answer must be 2 by 2 and cannot be lain. Okay, and this is an example. Given that A equals to 1, 2, 3, 4, B equals to 2, 3, 4, 5. Now I want to add these 2 matrices together by using this thing. We add as usual, and now we add together. We add together corresponding element for their corresponding element. For example, 1, this one plus with this one. A plus B, 1 plus 2. So you can get the answer like this. We add up together or can be minus together. Now, if I want to add up the number, the matrix means I repeat the addition many times for n times. So I can make it simple. I don't want to make it too long. If I want to add many times of the same matrix. For example, if I want to add up the A matrix with n times, I need to A plus A plus A plus A until the n times for A. So from here we can say that the n is a scalar. I can make it simplify become like this. Because actually we are doing multiplication. It's actually the same that you learned before. You know how to 2 times 3. When you write 2 times 3, you can say, oh, 2 is added 3 times. 2 plus 2 plus 2. So 2 times 3. Same in this. Okay, this A matrix is multiplied, is added in 3 times. So 3A equals to 3, the matrix ABCD. Okay, this one we call it as a scalar multiplication. Penerapan skala. Okay, and this is the first step. The first condition is that you can say that one number times with one matrix. If I want to make 2 matrices times together, what is the condition? If the matrix has an order of m by n, another matrix has an order for np, then these two we can multiply together and performing the order m times p. How we know this? We can use this one. This one is came from textbook, but I think you don't understand about this. If I want to say, if these two order, the first matrix, if its last number is the same as the second matrix first order. For example, 2 times 3, 3 times 2. The behind and the front is the same. Here also 3 and here also 3. So I can say the final answer we can get 2 by 2. How? If you do know, I give you an example. This is a 2 by 2, 2 by 1. So I want to multiply together. Yes, both can multiply together. Okay. You need to know about this concept. When we want to do anything about matrix, remember, baris laju. So baris laju. Whenever it's a 2 by 2 or n times n, anything, the first matrix you must baris, row first, and the second matrix we do column, row, column, row and column. Then when you do like this, you can get that this one. Then this is actually telling you your final answer can be this form. Means you got 2 answers for the matrix. So how do we multiply it? Okay, the baris, the row, okay, we add, and for column, row times with the column, row, column, and the row we add together. Okay, and the bottom one also same thing. Then we will get the answer. We see another example like this. Here is 2 times 2. Here also 2. This one is 2 times 3. If I can say that, okay, the behind and the front is the same. Okay, continue do. Whatever it is 2 times, either it's here or here is actually a same. Actually, we can do the same job, but you need to see this one actually can do the matrix for multiplication or not. It cannot. We cannot do the multiplication. Okay. Remember, PQ is not always equal to QP unless I can say that. Okay, like this. Okay. Let's see the answer first. Okay. Row, column, row, column. This is the first row, second row, third row. Remember, the row must be asingkan. Differentiate asingkan. You cannot together, make it together. Okay. PQ equals to QP. When I said that both are the same order, why can you say that? PQ equals to QP, AB equals to PA. If I say that this one is a new knowledge for you, identity matrix. Identity matrices are the square matrix. For example, okay, you see this. Okay, this is an identity matrix, means the diagonal shape, the diagonal one, each represent 1. Each represent 1, and everything outside from the diagonal line we make as 0. If you get the final answer is not a number like this, then that thing we don't call as a inverse matrix or identity matrix. So both are not identity matrix. What we can use for this one? Identity we can use for inverse matrix. Inverse matrix means, okay, this is the original matrix. I convert it to another matrix. I inverse it. Terbalikan. Okay, songsang, terbalikan. This is my original, this is my inverse by using a formula. If I can say that these two is the same, if I times it, I can make it become like this. Okay, so I can say that B is a inverse matrix of A. Okay, I change it because to A inverse, then you know why I say that. Okay, how do we convert from a normal matrix to a inverse matrix? By using this formula, A inverse equals to 1 over AD minus BC, and this matrix we change like this. AD we convert the we change the place. Okay, for the BC we put the minus sign, the negative sign, or we can say that, okay, I negate it. Okay, if here got negative, I put positive. If here no, I put negative. And remember, AD minus BC cannot be 0. It can be a 0, it means the inverse matrix is not S6. Okay, this is a formula that we commonly use to finding one thing. Using matrix method to solve simultaneous linear equation. So first, you can do the equation as usual, but you cannot do it in simultaneous equation. Okay, we show this equation. You are shown this equation. Okay, you have marks. You make it become a matrix form. The numbers are here, just stay alone. And for the same variable with x here and y here, asingkan, differentiate it. So here we stay alone, here also stay alone. And the first number must be in the first, in the second. You can try it to make this to, you multiply it, and you will get the same answer. You can trust me. Okay? And the behind one, just put PQ, just let it there. And this form is present, you have marks, and later on you make the xy as a subject to you put this one beside here, and you will do the inverse matrix. by doing 1 over AD minus BC. Okay, and then you do this one, then you get the answer for X and Y. So this is a quite easy question for you, quite easy chapter. And now we move for one question. This is for matrix. When you want to make this simultaneous equation become a matrix form. Okay, first, how you do that? First thing, you make all the alphabet in a side, number in other side, asingkan, okay, and you represent like this. You will represent like this. Numbers differentiate it. Okay, alphabet differentiate it. Okay, see, because I made 4n here and the 3 outside here, and I made this 2 outside, so here got same alphabet. Okay, remember, must be same alphabet, same format. Then you can do this. You take out all the number and present like this. That is the final answer. Okay, and try for this question. As I say that, okay, this is the inverse. This is the inverse of this in this matrix. And I said that this is a identity matrix because I said that okay, yes, I say that this is the inverse matrix and this is the normal matrix. So calculate the values of P and Q. So what I know about this is I say that it is a identity matrix. Identity matrix has the characteristics of, okay, these two, when I multiply together, I will get this answer. Okay, so how we do? We make this to become an inverse matrix first, and later on we compare together like this. We compare, you get the answer for P and Q. This is an easy question. Now we try for the question. Okay, now a supporting effort for the tourism campaign planned in 16A, a tourism authority intends to implement 2 times of the promotional package as in the table 6. It is the table, okay, and the government plans to produce 77 banners and 86 social media ads. Using the matrix method, determine the number for each promotional package chosen. So it means package A, I can get 3 banners plus 2 social media ads. And okay, for the package for this one, okay, like this. Okay, and government want to produce 77 and 86 social media ads. We see together. Okay, 77 banners. 77 banners. Okay, banners. 3, 2, this is the B, this is the S. And this is for package A, this is for package B. We need to find the number for each package that chosen. Okay, and we need to find X and Y. Okay, how many you can do in this package and this package? Okay, show like this, you got 1 mark, and do this one, got another 1 mark. It's quite hard for this question, but I can try for this one. Okay, Archimede, okay, Archimede and Xiuling. These 2 people want to go to buy drinks. Okay, here got grape, here got orange. Okay, and the Xiuling, okay, buy 2 grape, 3 orange. Archimede, 4 grape, 5 orange. And then you say that Archimede paid 34 ringgit to buy these 2 bottles. Okay, and then the Xiuling pay less than 60 ringgit then estimate. So it means, okay, if, okay, estimate 34 ringgit, ceiling less than 16, 34 minus 16, you get 18 ringgit. So ceiling paid 18 ringgit to buy 4 grape and 5 orange. By using matrix method to find the price of the bottle of grape and the orange. So whatever you can do, you can make it as a G, make it SY also can, but you need to label what is that to let the examiner to understand your answer. So you can show like this, like this. Here is the answer. Okay, you show this one, you got 1 mark. You have this one and 1 mark, and you do this one and another 1 mark, and your final answer 6 ringgit, 2 ringgit. That is your final answer. Okay, to conclude, okay, what we learned today? We learned about matrix. Now, okay, we need to know how to represent all the elements in a matrix. And equal matrix we can use for to finding the unknown number in the matrix equation. Then we know how to plus, how to minus, how to multiply by a number for the matrix or multiply two matrices. And also we know what is a characteristic for identity matrix. And from identity matrix we can make it inverse matrix, and all these things we can use it for solving simultaneous linear equation. Because this is a free class, if you want to know more about this chapter, okay, you can participate my one-to-one tuition class, okay, by via contact my WhatsApp number in the description and the chat box below. And for the practice and the notes you given in the chat box and also the description. Okay, so don't worry, everything just give you. If you want to let me mark your answer provided, but I also can mark your answer and give you some explanation and advice about this. So I'm your maths advisor, Sheku Chen, and that's all from today. Thank you so much and thank you for watching. And we will see in the next class. Goodbye.